Welcome you all back to my YouTube channel. This is my official channel, so if you are new, consider subscribing. And in this lesson, we are going to talk about radioactivity with exam questions. So we are going to summarize what radioactivity is so that we may answer each and every question that may try to come in an exam. So I wrote down this definition of radioactivity where I said radioactivity is the spontaneous breakdown of an unstable nuclei emitting alpha and beta particles and gamma rays. So this is the definition which I wrote down for radioactivity. So whenever you are talking about radioactivity, this is just a spontaneous breakdown. The other term that we can use is integration. So this is the spontaneous integration of unstable nuclei emitting alpha and beta particles and gamma ray. So the sentence itself can tell you that alpha and beta, these are particles. But whenever you're talking about a gamma ray, this is a what? This is a ray. It's different with these particles. So under radioactivity, we study alpha particles, beta particles, and gamma rays. These are the three things that we are going to concentrate so much in this topic. So when you understand what the definition of radioactivity is, you just say this is a spontaneous breakdown. So some elements which radiate energy of itself without any excitation from the outside is called radioactive elements. And you can also say, whenever you're talking about a radioactive element, so when we say this is a radioactive element, I want you to understand all this. When I say this is a radioactive element, this is an element that can also undergo what? Radioactivity. So if they ask you what is a radioactive element, a radioactive element, this is an element that undergo radioactivity. E.g., whenever we are talking about uranium, these are examples. Uranium, we can talk of radium, you can talk of thorium. These are the most elements that we usually concentrate so much whenever we are talking about radioactivity. So, I've told you that some elements which radiate energy. So these are the elements which radiate what? Energy of itself without any excitation from the outside. These are the examples of those elements. So these are the elements which undergo radioactivity. So from the definition, radioactivity is taking place when the nucleus of an atom becomes unstable. So when it becomes unstable, it is going to break down. So when it breaks down, it is going to emit or radiate these one of the three particles here. So it can radiate or it can release a what? An alpha particle, or it can release a beta particle or a gamma ray. So these are what we are going to study in this lesson. We are going to understand what happens when an element radiates an alpha particle. What happens when an element radiates a beta particle? What happens when an element radiates a gamma ray? So this is what we are going to measure so much. So in this now, what we need to know and understand is that elements that show radioactivity elements, these are the elements that show radioactivities. These 1, 2, 3. These are just examples. We've got a lot of these. We can understand all these properly. So now, the other thing that you need to know before we go any further, you now need to understand the characteristics of these elements. So you need to understand the characteristics of these. You need to understand the characteristics of the what? Of the emissions. These. So you need to understand the characteristics of the what? Emissions. What is the character of an alpha particle? What is the character of a gamma ray? What is the character of the what? Of the beta particle? So what we need to do, we are going to summarize this in a proper way. So I'm going to say This is what you are going to understand. So I'm going to summarize this so that everyone can get the concept. Everyone can understand what I'm trying to say. So I'm going to say, here I'm going to say this is an alpha particle. So I'm going to put here an alpha particle. Here I'm going to say this is a beta particle. And this is a gamma ray. This is what I'm going to do so that each and every person can understand. So this is what we are going to discuss about. This is what we are going to understand. So here, what is the nature? So let us talk about the nature now. So by nature, so this will be like this. So by nature, what is an alpha particle? You need to understand what an alpha particle is. By nature, what is a beta particle? By nature, what is a gamma ray? So whenever we are talking about an alpha particle, this is the what? Helium nucleus. You need to understand that an alpha particle is the helium nucleus. Not helium, but we focus on the nucleus of helium. And how is the nucleus of helium? It is like this. 2 here and a 4 there. So this is the nucleus of helium. So by nature, an alpha particle is the helium nucleus. Then what is a beta particle? A beta particle, by nature, a beta particle, we just say this is an electron. So this is an electron. That's why if you are told to define a beta particle, we just say that a beta particle is a fast moving electron. That's how we get to define a beta particle. This is just a fast moving electron like this. So we can symbolize this, a negative. Electrons are being symbolized by a negative there. Then by nature, what is a gamma ray? What is a gamma ray? So a gamma ray, this is an electromagnetic wave. Electromagnetic wave. So this is just an electromagnetic wave. This is what you need to get. So I've explained these three. By nature, an alpha particle is an helium nucleus. By nature, what is a beta particle? A beta particle is an electron. By nature, what is a gamma ray? A gamma ray is just an electromagnetic wave. Now, let us now go to the charge. What is the charge of these three? So, what is the charge? So, we focus on the what? On the charge. So, what is the charge of an helium? What is the charge of alpha here? What is the charge of alpha? The charge of alpha is positive. So this is just positive. The charge of an alpha particle is positive, which is positive 2. That is the charge. What is the charge of a beta particle? The charge of a beta particle, this is just a negative. Have you seen? This is just a what? A negative. This is just negative 1 like that. So this is just a negative. Then what is the charge of a gamma what? A gamma ray. So the charge of a gamma ray, it is just 0. Or we can say this is just neutral. So we can use these words. I can say this is what? This is 0, or I can say it is what? It is neutral. The charge of a gamma ray, this is 0. Have you seen? So these are what you need to know and understand. So we also go to the mass. What is the mass? So I'm going to summarize this so that we understand everything that I would say. So we go to mass. What is the mass now? What is the mass? So the mass here, the first one, this is what? This is an alpha particle. So what is the mass of an alpha particle? The mass of an alpha particle, we focus on the what? We focus on that mass there. What is the mass? The mass number 4. So here the mass is what? 4. The mass of an alpha particle is 4. Then what is the mass of a beta particle? A beta particle, we've said that this is an electron. So what is the mass of an electron? The mass of an electron, we say this is what? 1/8040 like this. That's why sometimes we say an electron doesn't have any mass because this is too small. If you punch this on a calculator, you discover that you're going to have 0.00 just like that. The numbers will be at the end, which is just the same as this is a small mass. Have you seen? This is just a small mass. Then what is the mass of a gamma ray? What is the mass of a gamma ray? So the mass of a gamma ray, this is 0, doesn't have any mass. This one doesn't have any mass. Have you seen? So I want you to understand this, and I want you to get this. This one doesn't have any mass. There is no mass with the what? With a gamma ray. I move to the other part. Which is where can we absorb these elements, or where can we absorb these particles. So I'm going to say they are absorbed by, so these are absorbed by, so the first one, this is a what? The first one is an alpha particle. So an alpha particle is, so the absorption of an alpha particle, where can we absorb an alpha particle? Where can we absorb an alpha particle? So we use what? We use a sheet of paper. So this is just a sheet of paper. A sheet of paper. Have you seen? This is what you need to understand. Just a sheet of what? A sheet of paper. Then we go to a beta particle. Where can we absorb a beta particle? A beta particle can be absorbed by 5 millimeters of aluminium. 5 millimeters of aluminium. This is what you need to know and understand. We go to the last one, which is a gamma ray. So a gamma ray, we use 5 centimeters of lead. Have you seen? Like this, 5 centimeters of lead. So these are what you need to know. These are what you need to understand. So we can just be going mentioning these characteristics. So you need to make sure that you know and understand these characteristics. If a question comes in an exam, where can you absorb an alpha particle? We use a sheet of paper. Where can you absorb a beta particle? We use 5 millimeters of aluminium. Where can you absorb a gamma ray? We use 5 centimeters of lead. This is what you need to know and understand. We also talk of their penetrating power. So whenever we are talking about the penetrating power, so like some of these things you need to understand them. So penetrating power, I'm going to write this. Whenever we are talking about penetrating power, have you seen? This is what? Penetrating power. So penetrating power, how strong are they? So when we are talking about the penetrating power, we are mentioning these in terms of their comparison. So there are about 3. So in terms of comparison, which one is very strong? Which one is got the strongest penetrating power? So the one which has a strongest penetrating power, it is a what? It is a gamma ray. So this one is very strong. Have you seen? This one is very strong. This one has got the highest penetrating power, a gamma ray. You discover that when we are talking about the gamma rays, we are talking about these are rays which can cause cancer. So whenever a person exposes themselves to gamma rays, they can develop cancer. And if a person with the cancer exposes himself or herself to this gamma ray, they are able to cure the cancer. So the same thing that causes cancer can also cure cancer. These are gamma ray. We discover that the dangers of gamma ray is that they causes cancer. And what is the use of this gamma ray? They can cure what? They can cure cancer. Then you go to a beta. So this beta is what? Is weak. So we are going to say this is weak. This is weak. Then an alpha particle is very weak in terms of penetrating power. You see, this one is very weak whenever we are talking about the penetrating power. So an alpha particle is very weak, but a beta particle is weak. Then this one is strong. Have you seen? This one is what? This one is strong. This is what you need to know and understand. So this is what we need to know and understand. We can also go further and look at the ionization effect. We can look at ionization effect. So we can also look at ionization effect. So this is the last one that we are going to talk about, ionization effect. So we can talk of ionization effect. So in terms of ionization effect, what we are talking about is that we are also going to give these in their comparison. Which one has got a strong ionization effect? which one has got a weak ionization effect. So the one with the highest ionization effect is an alpha particle. So we are going to say that an alpha particle is very strong. So I'll say very what? Very strong. An alpha particle is very strong. An alpha particle is very strong. An alpha particle, this one is very strong. Then we go to this other one. So you can say very strong, strong, or weak. Or you can start with strong, weak, very weak. You are giving a comparison. So these ones are what? They are, I'll go with what I wrote at first. So I'll say these ones are strong. So I'll go with this. I'll say these ones are strong. And then a beta particle is weak. Then this other one, which is a gamma ray, these are very weak in terms of their ionization effect. They are very what? They are very weak. So this is what you need to understand. So don't forget, this one is for, these are the characteristics of alpha particles. These are the characteristics of the what? Beta particles. And the last law here, this is the characteristics, this last column, these are the characteristics of gamma rays. So this is what you need to know. This is what you need to understand. Make sure that you understand this, you know all this. The same way I've explained, I was talking about nature, the charge, the mass, where they are absorbed, the penetrating power, ionization effect. So this is the ionization effect. You can also talk of that. We can also go further and talk about the range in air. So what is the range? So the range in air, like this. I'm going to say this. What is the range of this? So what is the range in air? I'm going to do this. What is the range? So whenever we are talking about the range of this, it's just a few centimeters. Have you seen? A few what? Centimeters. So here we are talking about a few centimeters. This is what you need to understand under the what? Under the alpha particle. So under the alpha particle, the range in air just a few what? Centimeters. This one, which is a beta particle, it is just what? A few meters. This one is in meters. Have you seen? This one is in meters. Then now we move to this other one. So we are talking about the what? The range. We move to this other one. So this other one, we were talking about, whenever we are talking about the range in air, you discover that this one is a few what? Centimeters, a few what? Meters. But this one, which is a gamma ray, hundreds of what? Hundreds of meters. So this one has got more than hundreds of meters. So this one is more than hundreds of what? Meters. So I want you to understand this. More than of hundreds of what? Meters. So this is their range. So this is the what? Their range. So this is what you need to know and understand under this. So I want you to get this, and I want you to understand everything here that I've explained. So we are making radioactivity very simple, so that if any question comes in an exam, you are able to answer it, you are able to handle everything. You won't fail any question that will come. So far what we've covered under the characteristics, you are able to answer them, you are able to go through these things. So I want you to understand this, and I want you to get the concept. So if you are new to this YouTube channel, don't forget to subscribe, don't forget to like the video, and to comment. Okay, so let us now go to the other part. So we are still under radioactivity. There is also another part which we call radioactive decay. Let us talk about radioactive decay. So we talk about radioactive decay. So we need to talk about radioactive decay. This is what we are going to talk about. Radioactive decay. So this is what we'll talk about. Radioactive decay. So radioactive decay, this is a decay that shows the changes that happens when an element emits an alpha particle, when an element emits a beta particle, when an element emits a gamma ray. So this is what we get to talk about. So if a substance has the atomic mass 82, let's say substance has the atomic mass of 82, the nucleus of unstable and tends to break down into smaller parts. Have you seen? Then this breaking, it can be an alpha particle, it can be a beta particle, it can be a gamma ray. So this can be emitted from its nucleus. So this is what we talk about, what? Radioactive decay. So this is what you need to know and understand. So if an element or a substance has got the atomic mass of 82 in its nucleus, so when it decays, it is going to break down. It is going to do what? Break down. So when this breaks down, it will emit either one of the three. It will emit either an alpha particle. We use that symbol to symbolize an alpha particle. We can use a beta ray. It can emit a beta ray. So that is the symbol for a beta ray. It can also emit a what? A gamma particle. A U, something like a U, like a Y, something like a Y. Have you seen? Like this. So when an element undergo radioactive decay, the following happens. It will emit either an alpha particle or a beta particle or a gamma ray. This is what gets to happen. So each time an element undergo a radioactive decay, one of these things will happen. So one of these things will take place. So now, what happens? Let us talk about alpha decay now. Let us talk about alpha decay. How can we know that it has undergone alpha emissions? So let us talk about alpha decay. So we talk of alpha decay. What is alpha decay? So we talk of alpha decay. The symbol for alpha, don't forget the symbol like this. This is the symbol for alpha. So we talk about the alpha decay. What do we understand by alpha decay? Or what happens when an element undergo alpha decay? So what happens when an element undergo alpha decay? So what happens, you need to talk of the mass number. You need to understand what happens to the mass number. This is what you need to know. Or what happens also to the what? Proton number. So these are what you need to know. The mass number and the proton number. These are the two things that we need to talk about. So what happens to the mass number? The mass number, whenever an element undergo alpha decay, the mass number, it reduces by 4. So this one reduces by what? Reduces by 4. Then, whenever we are talking about the proton number, what happens to the proton number? The proton number also reduces. So this one reduces by 2. Have you seen? So it reduces by what? It reduces by 2. So whenever you're talking about alpha decay, so when an element undergo alpha decay, the following happens. These are what happen. So when it undergo alpha decay, the mass number reduces by 4. The proton number reduces by 2. This is what you need to know and understand. Have you seen? This is what you need to know and understand. So we need to understand these things. So let us talk about let us bring out this element as an example. So we bring this element as an example. You've got this element. This is an element like this. This element has got the mass number of 226. Then the proton number is 88. Like this. It is like this. So when this undergo alpha decay, what will happen is that when it undergo alpha, I'm going to do this alpha like this. So I'm going to put a symbol for alpha there. That's the symbol I'm going to put. So what the element that will be formed, I don't know it. So I'm going to put X like that. Then you know that the mass number there will reduce by what? The mass number will reduce by 4. So what is 226 minus 4? You are going to get about 222. Have you seen? So that will be your new mass number. Then the proton number will reduce by 2. So what are we going to have? We are going to have what? 87. 6. Then you say plus. It had to undergo what? It had to undergo alpha decay. So you say H like this, then you put a 2 there, then you put a 4 there. This is what you need to do. So this is what? This is alpha decay, showing that this element has undergone alpha what? Alpha decay. So this is an alpha decay. So in general, the equation that we get to talk about, or the equation that we need to know. So the equation that we need to know in general. So in general, what we are talking about, the general equation, this is the general equation that will now help you. So let us say we've got an element X. This is an element X. It has got the mass number A. Then the proton number, we use Z like this. So when it undergo alpha, I'm going to do this alpha. I need to put the symbol there for alpha, showing that it had to undergo alpha decay. Then what the element that will be formed here, I don't know it. I'm going to put what. So these are elements. Have you seen? So the element I don't know, I'm going to put a Y there. So this mass number will reduce by 4. So A minus 4. Then the proton number will reduce by 2. So I'm going to say Z minus 2. Then I say plus what? The helium now, which is a 2 there and a 4. So this is the general equation that we get to talk about. So this is the general equation that you need to know and understand when we are talking about a gamma what? An alpha decay. So an alpha decay, this is an equation that we need to know. This is an equation that we need to understand. So let's make sure we get this concept. This concept will really help us in our study of radioactivity. So this will really help us in our study of what? In our study of radioactivity. Once you understand all this, everything becomes simple. So any element that you will be given, let's say the way questions will be coming in an exam. So you need to be sensitive so much. So they will ask you a question in an exam to say, they will give you an element. So they will say, okay, we've got an element. Let's say, this is just an example. Have you seen? This is just an example. I'm just going to put this as an example. I'm going to say this is X with the proton number of 88. This is just an example. Then the mass number is what? Then the mass number, I'm going to use 138. This is just an example. This is just an example that I'm giving. You've got this. So they'll tell you that if this undergo alpha decay, so when this element undergo alpha decay, what is the mass number of an alpha particle? Have you seen the way I've phrased this question? So when it undergo an alpha decay, so it will be like this. What will be formed here, we also don't know. But we know that this one will reduce by 4. So we are going to have 134. This one will reduce by 2. We are going to have 86. Then plus what? Plus helium like 2 and 4. Then they ask you that what is the mass number of an alpha particle? An alpha particle is this one. So when they say the mass number of an alpha particle, you just say a 4. What is the proton number of an alpha particle? It is a 2. But if they say what is the mass number of the new element that is formed, that's when you go to this element which is what? Which is formed. So we need to make sure that we are sensitive to these questions. We understand them clearly. We see how they come in an exam, because just a simple mistake can really cost you in an exam. So I want you to get this, and I want you to understand all the principles. So I've showed you that this one here, this one that I wrote there, this is the what? This is the general equation of alpha decay. This is a general equation of alpha decay. So this is what you need to know. These are what you need to understand. So let us now move to the other type of decay, which is a beta decay. So what happens if an element emits a beta particle? What happens? So everything remains the same. Here, everything will remain the same. I'm going to do this. So I'm just going to label. that one there. So I'm talking about what? Beta now. I'm talking about beta decay. So we are talking about beta decay. The symbol for beta. What is the symbol for beta? This is the symbol for beta. It is like this. This is the symbol for what? This is the symbol for beta. So these are what we need to know and understand. This is the symbol for beta. So we talk this in terms of what? So we are going to talk about this in terms of mass number and proton number. So if an element undergo a beta decay, when it emits a beta particle, what happens to the mass number? What will really happen to the mass number? So when an element undergo a beta decay, what happens is that the mass number remains the same. Have you seen? The mass number will do what? Remain the same. The mass number remains the same. So this one remains the same. Remains the same. This one will remain the same. Then the proton number increases. I want you to understand this. Increases. Increases by what? Increases by 1. So this is what happens when a particle, when an element undergo alpha decay. I mean beta decay. So when it undergo beta decay, what happens is that the mass number remains the same. The proton number increases by 1. So this is what you need to know and understand. So under beta decay, mass number remains the same. Proton number increases by 1. This is what we need to know and understand. So what is the general equation now? What is the general equation? So before we talk about the general equation, I want to give this example. Let's say we've got this element. So this element, this is an element. You are given this element like this Pu. Then the proton number 94 there. Then this one we've got 241, which is our mass number. So when it undergo, I do this. When it undergo beta decay, I put a beta symbol there. A beta decay. What happens that the new element that will be formed, I'll put X because I don't know it. I don't know the element that will be formed. So what happens to the mass number? The mass number remains the same. So 241. This one will remain the same. Then what will happen to the proton number? The proton number increases by 1. So we are going to have 95. Then I say plus. Plus what? What am I going to form here? Then I'll show that this was an electron, which is a beta particle. Like this. Have you seen? You show that this was an electron. By nature, a beta particle is an electron. You show that electron like that. So these are how you need to be writing these things. This is how you need to be writing this. So this is an equation. So if you are given this, then you are told that it had to undergo beta decay. This is what we mean, or this is what gets to happen. So I want you to understand this. So if you are watching this video, let's make sure that we share this video with others so that we get to benefit together. So now, what is the general equation for a beta decay? What is the general equation for a beta decay? So general equation, what is the general equation? Which general equation are we supposed to know? So the general equation that we are supposed to know, I'll just say, let me say X. X is an element like that, which I don't know. So we've got the mass number A, then the proton number Z. So when it undergo what? Beta decay. When it undergo beta decay, what happens that here, the element which is formed, so I'm using these letters, so the element which is formed here, this mass number remains the same, but the proton number Z increases by 1, so Z plus 1, then you say, you put the electron there, 0 there, and the -1 down there. So this is how you need to be knowing these things. This is how you need to get them, understand them, and know them. So I want you to get this, understand this, and know all the procedures that I'm doing. So this is the general equation. This is what you need to know. This is what will really help you in your exams. So this is a general equation. So when it undergo a beta decay, this is what you need to know in terms of the mass number and the proton number. This is what you need to know and understand. So let's make sure that we know all these, we understand everything here that we are trying to say. We make sure that we understand everything that I'm trying to explain here. So I want to make radioactivity very simple so that we know and understand one or two things. But we need to make sure that each and every question that may try to come in an exam, we are able to answer it, we are able to know how to do it. So this is what you have to know, this is what you have to understand on this. So let us now move to the last one under these radioactive decays. So we move to the last one. So the last one is a what? The last one that we get to talk about is a what? Is a gamma ray. So a gamma ray, we talk of a gamma ray. We can symbolize this to do that something like a Y like this, like that. So that is a what? A gamma ray. So what happens to the gamma ray? So the radioactive decay emitting a gamma ray from the daughter nuclide is called a gamma ray or a gamma decay. So when some nucleus emits this one, or when it emits let's say when it emits an alpha particle or a beta particle. So when it emits an alpha particle or a beta particle, they leave the nucleus unstable. Have you seen the news? They leave the nucleus in unstable energy condition. So these ones, they do what? The nucleus emits an extra energy by what? A gamma ray. So what happens whenever an element undergo a gamma ray is that the mass number, what happens to the mass number? The mass number and, so the mass number and proton number. So I'm going to this. Mass number and proton number remains the same. Everything remains the same. Remains the same. So nothing will change. Everything will just remain the same. This is what you need to know and understand under gamma ray. Everything will remain the same. So then the general equation that you need to know on this. So the general equation on this. The general equation on this. Simple general equation on this. So what is the general equation under this? The general equation that we need to get is that this one, let's say we've got an element X here. This is an element. The proton mass number A, proton number Z, emits a what? It emits a beta, a gamma. So it emits a gamma ray. So when it emits a gamma ray, everything remains the same. To just be the same. Obviously, everything will remain the same. Then just say plus. Then you put a gamma ray here. You say gamma ray. That is, so this is the general equation. Everything remains the same. Everything will automatically remains the same. So this is what we need to know. This is what we need to get and understand. This is an important topic that you need to understand in physics, radioactivity. You need to make sure that you know it. You need to make sure that you understand it. So we need to make sure that we understand everything that I'm trying to say here. So any question that may try to come under this, with this information that I've given you, you are able to answer it. You are able to go about that question. You are able to answer it. So the last part which we talk about under radioactivity, it is called the half-life. So we need to understand what half-life is. So we talk of what? Half-life. So what you need to understand under this, the last part that we need to know is half-life. So what is half-life? We need to know what half-life is. So this is what this is the last part that we get to talk about, which is what? Half-life. So what is half-life? So half-life, of a sample of radioactive element is defined as the time taken. So time taken for a substance. So what substance are we talking about? So this is just a time taken for a radioactive substance. So this is a time taken for a radioactive substance. I'll say a radioactive. So this is radioactive. Time taken for a radioactive substance to decay. Radioactive substance to decay. To decay by half. So to decay by half of its present material. So by half of its present material, this is what we need to know and understand under half-life. So what is half-life? Half-life of a sample. Which sample? We are talking about radioactivity. So when I say a sample, I mean a radioactive sample. So this is a time taken for a radioactive substance to decay by half of its present material. So the time it will take for it to decay by half of its present material. That is what we are calling what? That is what we are calling our half-life. Half-life is just a time taken. So time taken. This is just the time taken. Time taken for a radioactive substance to decay by half of its present material. That is what? That is half-life. So we need to know what half-life is. That is half-life that we get to talk about. Time taken for any radioactive substance to decay by half of its present material. So that is just the time that it will take for any radioactive substance to decay by half of its present material. That is what you need to know and understand. So now let us look at an example. Let us look at an example. Let us look at an example under this so that we know. So an example under half-life, maybe you know this. So we look at an example. So this is an example. There are 1 kg. So there are 1 kg of strontium, which is like this, S small letter r, that has the half-life. So that has the half-life. So it has the half-life of 30 years. So half-life of 30 years. So the half-life of 30 years. Question 1. So the first question that we are going to talk about. Question 1. How many grams? So how many grams? So we are talking about grams. How many grams of what? How many grams of, so grams of this same element that we are talking about, which is what? Strontium. So how many grams of strontium are remained? So these which are remained after what? After 60 years. So how many are going to remain after what? After 60 years. This is what you need to know and understand. How many will remain after 60 years? So let me just say 90 years. Let me just put 90 years. After 90 years. How much will remain after 90 years? Then the other question, so I want to summarize this. The other question that we are going to talk about. So let me first answer this question so that we know and understand. We get this example and understand. The question is saying there are 1 kg of strontium, which is SR, that has the half-life of 30 years. So the question is saying how many grams of the same element, which is that one, strontium, are remained after 90 years. So after 90 years. So what you are going to do, we are going to put a table of values that will help us understand this question, a table of values that is going to help us understand this question. So I'm going to do this. This is what I'm going to do, like this. So we've got, I'm going to say here, I'm going to put time. So I'm going to put time, which is in what? Years. Time is in years. I'm going to do this. Then here, I'm going to put the mass. I'm going to put the mass there. So this one, it is like this. When time is 0, time is what? Time is 0. But the mass will be in what? The mass will be in grams. The question is saying how many grams. So we've got what? 1 kg. So what is 1 kg in grams? It is what? 1000 grams. So 1 kg, when we convert to grams, it is what? It's 1000. So here I'm going to say grams. This is the mass in grams. So when the time is 0, when this decay has not happened, this half-life is 0. It is just what? It is just 0, like that. So we are told that the half-life is what? The half-life is 30 years, meaning that every after 30 years, the mass will be decreasing by half of it. So every 30 years, it will be decreasing by half. So after 30 years, it will decrease by half. After 30 years, it will decrease by half. So which means after 30 years, so say after 30 years, this one will decrease by half. It is going to be what? 500. So when 1000 divided by 2, it will decrease by half, which is 500. Then what after, again, after 30 years, so it is at 30, after 30 years, you are going to have a schist like that. So this one will decrease by half. So what is half of 500? This is what? 250. This is what you need to know and understand. Again, after 30 years, we've got a 90 there. Then what mass are we going to have? What is half of 250? The half of 250 is 125, like that. Meaning for us to answer this question, how many grams of strontium remained after 90 years? So 90 years it is here. Have you seen 90 years? So how many grams? So therefore, you just say therefore it is what? 125 grams. This is how you do it. It is what? 125 grams. This is the answer here, which I've even shown you how to go about it, how you can answer it, how you can handle such a question. So now, the way in which you can answer this question, if it comes under multiple choice section there, how you can go about this, it is very simple. This is how you are going to go about it. I'm going to show you the easiest way on how to go about this question, how we can move about this question, how we can answer it, how we can handle it. I'm going to show you all the steps. So I'm yet to do now another lesson where we'll be revising through past papers. So be revising through past papers, we are going to see how radioactivity comes. So stick connected to this channel. Make sure you've subscribed so that when I upload that lesson, you'll be able to see it. So this week I'm going to do that. So this is just lesson 1 under radioactivity, where I'm summarizing the whole topic. Then we look at some questions, how questions come in an exam. So what you need to do is that we want to find the mass here. So the formula will just say X is equal to, the mass here is the present mass, multiplied by half, you do that. Then you put the total time there. You say total time over half-life. Have you seen? This is what you are going to use. This is the formula that we get to use. So where you are going now to substitute. So you are going to do what to substitute. Where you are going to say this is equal to. What was the present mass? The present mass was 1000. You say half. Then what was the what? What was the total time? The total time was saying after 90 years. Then what was the half-life? The half-life was what? What was the half-life? The half-life was what? The half-life was 90. 30 was 30. The half-life was 30. Total time 90. Half-life what? Half-life 30. So you proceed and say this is now equal to. You say this is 1000. Have you seen? This is what? 1000. Then 1 over 2. Then you do that. what is this into that? What are we going to get? What are we going to get? We are going to get a 3. When you divide there, you are going to get a 3. This is just the same as what? 1000, like this, 1000, then multiply by. So when you press on your calculator this one, you just, instead of me writing this, this is the science calculators are around. So you say 1000, open bracket, 1 over 2, close to the power 3. You are going to get the answer there, which is what? 125 grams. This is another way in which you can answer this question. This is another way that you can go about this question. So I've showed you how you can answer this, how you can handle these things. So this is another way in which you can answer such a question. So this, don't make a mistake, you say 2 into 1. No, this one has got the power there. So before you divide it into that, first deal with the power there. This is 2 to the power 3, 1 to the power 3, which is being multiplied by that. So you press it the way it is, the exact way it is. So this is how we need to answer such questions. So I'm yet to do now a video and exam question, a past paper. I'm going to answer a past paper, how we can sketch this, how we can go about this one. So according to your understanding, how I've blessed you with this teaching, you can comment something there. I see in the comment section how many people I'm helping, how many people are appreciating. Thank you so much. So if you are, maybe you want tuitions in science, you are a GCE candidate, you can drop a text on this on WhatsApp. You can text me on WhatsApp, which is +26097 106 6747. This is my number, which is +26097 106 6747. You can call me on this number. You can WhatsApp me, then I'll be able to attend to you if you've got any question related to this. Thank you so much. Stay blessed. Look forward for the next lesson. Make sure you've subscribed, liked, and commented. Thank you.